Hey everyone, last thing about intermolecular forces in solids. I couldn't find a good YouTube video on this, so I made this picture to help illustrate. Some of these are easier to see than others. I'm going to discuss four types of solids here and the major differences and how some are held by different kinds of forces than others, and also how to look at one and predict its relative strength. Let's look at the first one. What I have here is a brass pipe fitting. Um, these are pretty strong forces because they're held by the metal cations and a sea of electrons that have an opposite charge in this particular model. Now, similar to that would be something like an ionic solid. This is road salt. It's similar to sodium bromide that helps melt all the snow on the sidewalk so that we can start on time today. You can increase the strength of an ionic solid if a couple of things increase, which is the charges of either the metal and the non-metal ions, or if you decrease the atomic radii because of Coulomb's law, the distance between charges decreases, thus strengthening the attraction. We have a rare type, something called a molecular solid, and this is iodine, and iodine is held only by London dispersion forces. Now, this is a covalent bond here between two iodine atoms, and then this covalent bond is polarizable. So you have large groups of electrons that can shift and oscillate back and forth that cause a momentary attraction between these oppositely charged electrons and the positive nucleus of another atom. These can increase as the size of molecules increases. Now, check out what's going on here. I just put this ion in the paper, and you guys see how it starts to stain? This would disappear if I left it overnight, because even something that has a lot of electrons, if it's only held by London dispersion forces, that's a kind of a weak intermolecular force, and this material typically will sublime, as we saw in an earlier class demonstration. The force of IMFs can increase if you had something like water that has hydrogen bonding, or if the size of the molecule or atom increases. If you're looking at the periodic table, maybe something that goes down on the periodic table would have increased attraction. Perhaps something like astatine. Bromine, for example, is a liquid, and that's because it has less electrons than iodine. Therefore, the London dispersion forces are weaker. Finally, we have covalent network solids. This is a piece of quartz crystal. These are easy to recognize because you have a three-dimensional network of covalent bonds. Morning. This 3D covalent network is typically seen with elements that can form multiple bonds. We might look at atypical elements, but that's all for now. So use this to help compare different types of materials and predict what kind of strength they would have based on some of the factors that I showed you here. Thanks.